Phil has actually recently retired from a 40-year career um, in the water and wastewater industry and is still splashing around a bit. To wit, he is, I mean, he was recently general manager of West Bay Sanitary District and now is working as a transition coach to the new general manager. He played a central role in West Bay's construction of a satellite recycled treatment plant with a membrane bioreactor and in the permitting process of the first on-site reuse treatment plant in the district's jurisdiction. He also was given the task of figuring out the interconnection with Facebook systems as well. So I was quoting the song Both Sides Now when we talked last, in that he was involved in a satellite system at Sharon Heights, which he'll show, and then also uh, is on the receiving end of the Facebook water reuse system as well. And so getting to Don Berger is a PE, water use consultant with West Yost, which is a consulting engineering firm focused exclusively on water. Um, so Don is a registered civil engineer with over 30 years of experience managing the planning, design, and construction of complex and multifaceted projects related to water recycling and wastewater treatment. I know he's been a tireless advocate for water reuse and the untapped potential of recycled water. He's been organizing things with Water Reuse California, and is very much an advocate for a balanced and diversified water portfolio. And every time I talk to Don, I get charged up. And so anyway, he's going to put forth the proposition that on-site reuse and decentralized treatment systems can help develop a more resilient and locally sustainable water supply. Who can say no to that? So I'm not sure it was Phil. Were you going first, or
Hi,
oh,
Dennis.
Don, I'm
I'm
sorry, Don?
first
You're
up.
going to run things. You're running up to slide
I'll,
20.
I'll be first at bat, so to speak. And thank
Take
you,
that
Dennis.
screen.
Thank you. Good afternoon, everyone. And let me. Okay. Now I'm trying to get my. There we go. Okay. You see that, Dennis?
Not yet.
Okay. Do I?
Have you pulled the? Have you shared screen?
I did. Let me try that again.
You have to hit that blue button.
Okay. How's that?
Good.
Okay. Good to go. Thank you. And I'm as Dennis said, I'm Don Berger with West Yost, and I'm joined by Phil Scott this afternoon of West Bay Sanitary District, who will be co-presenting with me today. We have two very interesting case studies to present on permitting decentralized recycled water treatment plants. The first is the Facebook project, which many of you have heard about. I think, in fact, they've presented to SSV in the past. And the second is the recently completed Sharon Heights golf course in Menlo Park. These are presented from the agency perspective to give you a feel for what issues a local sewer agency needs to consider when evaluating and permitting the waste stream discharges, in particular from decentralized recycled water treatment plants. And I know in the past, like I said, we've heard from Facebook and we've heard from the folks that are doing these, but I think you'll enjoy hearing what our perspective and experiences were from the permitting side, and also some lessons learned that hopefully will help others, as I know more of these are being looked at in the Silicon Valley area. And I wanted to point out just really quickly, while both projects involve decentralized treatment systems, a difference is the Facebook project treats and reuses the wastewater it generates on site from their own buildings. And whereas the Sharon Heights project is what we call a satellite recycled water treatment plant, as Dennis was mentioning, or a scalping plant is also called, which diverts and treats wastewater from the public sewer system for reuse on site. So those are two differences. And as I said, as you'll hear more today, as Dennis mentioned, there is an interconnection. So let's jump into the Facebook project here. This project came into existence in response to Facebook's incorporating an on-site reuse treatment plant, or we're calling it an ORTP here, into the design of two new buildings they were constructing at their Menlo Park headquarters campus. Like any recycled water treatment plant, these on-site systems produce not only a nice recycled water supply that for reuse, but they also produce a waste stream from the treatment process that needs to go somewhere for disposal. And this waste stream is typically discharged into the local sewer system. And as you'll hear, there's just not that many people that have done this outside of San Francisco. So this is a relatively new permitting experience. And in this case, of course, Facebook, the sewer system is owned and operated by West Bay Sanitary District. And so Facebook is connected into that. And it's typical for all municipal public sewer systems. New sewer connections do need a permit. And this all sounds pretty straightforward, perhaps at first thought. However, like I said, on-site commercial reuse in buildings in California is fairly new, except in San Francisco, of course, where they have a number of these systems and they have their own permitting system already. And so the Facebook system was the first of its kind for West Bay and the Menlo Park area. And as a result, the Facebook project required a new type of permit classification be developed because the discharge didn't fit into any existing standards or codes that were already in place. And Yost was hired to assist West Bay San in preparing new permit conditions for the Facebook project and to develop guidelines for permitting future systems that may be proposed as well. So just a quick orientation for those of you who are not familiar with Facebook campus. It's in southern San Mateo County, just east of Highway 101, next to the Bayshore. This is the view you'd see if you were perhaps a drone flying in a plane over from the Dumbarton Bridge. And as you can see, this is quite an extensive campus. The on-site reuse system for this project, it treats wastewater from two of Facebook's newest buildings. They're buildings 21 and 22, which if you look at the top arrow here, that points to just about where they are right up here. But you can see this is huge. This is all the new campus. And this over here is called their classic campus. It's part of it, but that was the old Sun Microsystems campus. And just a close-up photo looking now back towards the Dumbarton Bridge. And I wanted to mention here that these buildings were designed by the noted architect Frank Gehry. Many of you have heard of him. And as you can see, these are just beautifully done. They have extensive green roof systems that you can see here and wonderful gardens on the top. And in the two buildings that are served by the on-site reuse system, about 9,000 people will work in these two buildings. However, of course, due to COVID, these are currently unoccupied. And I wanted to just give you some stats and show you some pictures of the system. This is a black water treatment system for Facebook. And it is currently the largest on-site reuse black water system in California. And I understand it's also one of the largest district scale or multi-building projects in the US. So it's pretty substantial. It's designed to treat 90,000 gallons per day of wastewater generated from the buildings, and membrane bioreactor and reverse osmosis treatment system. And in fact, up here to the left, you can see this is actually fairly compact. This is the room where the equipment is located. There's the RO modules, and in the back is the MBR system. And that's an advantage of these MBRs, is they're very compact. And on the right here are some holding tanks for wastewater and recycled water. And they will be using the recycled water for toilet and urinal flushing and on-site for landscape irrigation. They had wanted to use it for cooling towers, but unfortunately there just wasn't enough wastewater available, especially due to the low flow fixtures that are now required by the codes. So I guess we never thought that we'd run out of wastewater. Maybe that's could be a good thing, less, but depending if you want to reuse it or not. This project was in the final stages of permitting with the regional board and Division of Drinking Water before COVID hit. And that startup testing got interrupted earlier this year. And I think the hope is, from talking to Facebook, that if things improve and people can get back to the office, that they could finish the startup of this and get it online later this year. So stay tuned for that. And wanted to also just illustrate the flow through this system. The wastewater, of course, comes from these two buildings, flows into the on-site reuse treatment plant, and about 68,000 gallons per day of water, recycled water, is produced for on-site irrigation and toilet flushing. The system also discharges a waste stream, which has to go somewhere, and in this case, back to the West Bay system, and it includes a brine stream from the reverse osmosis process, because the salts become concentrated. There's a waste sludge from the biological treatment process, and the screenings, which are from things like wipes that get down into the sewer system, and that all has to be removed to go somewhere. And as I mentioned, when people are working on the design of these on-site systems, the waste discharge component can end up becoming a bit of an afterthought, because we're so focused on the water reuse component and all the LEED, green benefits and everything of these systems, that it can be overlooked in the early stages of development. And also a point to note is that the waste streams from these treatment plants are different from the municipal sewage that you'd find out in the public sewers, is that they are very concentrated, high suspended solids, in this case, high salinity and TDS due to the brine discharge. And so they need to be looked at differently. And the other thing I'll share with you is every sewer system is really unique, and that some have more assimilative capacity than others, and some don't. And you really don't know until you've evaluated the specific discharge, the point of discharge, and taken a look at that. So that's why these need a permit. And West Bay had two main permitting concerns regarding the discharge. The first was salinity. And West Bay was concerned about the high TDS because they are developing their own local recycled water system for the Bayfront area. They're going to be building their own recycled water treatment plant, which is going to be great. And so it's important for them to also control the salinity or salts in the wastewater as well. Just like we know that too much salt is bad for plants, it's the same thing. And also, independent of the recycled water concerns, high TDS in the discharge could potentially impact the downstream wastewater treatment plant, which is operated by Silicon Valley Clean Water. And that had to be evaluated as well. That's where the wastewater flows, by the way, from the West Bay system, is to Silicon Valley plant. So this, I think, illustrates with the numbers why TDS is a concern. Sort of the rule of thumb is you want your salinity for your irrigation water to be down around 450 or less than 450 to protect plants and landscaping. And West Bay's average wastewater is already a bit elevated at 700 in their trunk line. And Facebook's discharge, like I said, which is a concentrated waste stream, is about 2,800 milligrams per liter of TDS. And in the future, with more of these systems coming online, you could imagine, one may not necessarily be an issue, but if there's lots of them, then this needs to be looked at. Like I said, especially if the salt's being concentrated, it goes back into the wastewater system and has to be treated, or could increase salinity of recycled water produced. A second concern is the impact of the concentrated solids and screenings on the sewer collection system. And you can see in the middle here some pictures of pipes. Sometimes sewer lines get dips and sags. And so solids that get into the system, they can collect there, and they can lead to potential of plugging or clogging downstream pumps. And that could lead to more additional cleaning costs and maintenance expenses. So these were the two, so salinity and the biological solids, or the solids, were the two concerns. And as a result, local limits were developed to protect the sewer system and the downstream wastewater treatment plant at Silicon Valley Clean Water. These limits included salinity and solids limits that would also prohibit the discharge of screenings. With that, the issue with that is these limits, however, would require modifying Facebook's treatment system that they had already started constructing to meet the proposed more restrictive TDS limits and prohibiting discharge of screenings. And to do that, they would have had to install new process equipment and haul the screenings offsite for disposal at a landfill. And that would both be expensive and disruptive, and would be additional costs that weren't included in Facebook's plans. As a result, the permit as originally proposed would create some significant additional and capital costs, operating costs for Facebook that weren't previously budgeted. But there is a silver lining to the story, and I want to just mention, with all these issues at hand, the creative and problem-solving minds at West Bay and Facebook got together and came up with a novel permitting approach that was able to move the project forward. And with that background, I want to turn it over to Phil Scott at this time to tell you more about the permitting approach and some of the lessons learned.
Thank you, Don. Can you hear me okay?
Yes.
Okay, good. So we were concerned about the salinity, like Don said. We were worried about the screenings. So what we ended up doing is working with them on a provisional permit that would have allow a couple of variances to the screening requirement, as well as the salinity requirement. And over a period of time of 3 months, the provisional permit would be good for 3 months, and we would review it every 3 months and look at the data and see if, in fact, what their discharge is as far as salinity and or the screenings, and also give us an opportunity to assess the downstream sewer line to see if the screenings are having any effect or negative impact on loading of our sewer line going to the treatment plant, going to the pump station that then pumped it to the treatment plant. So we were able to come up with this approach for Facebook because it's a new type of discharge. It's not routine. If we can go to the next slide there, Don. And
okay. Oops, why are we not?
It's not moving.
Yes, mine is up.
There you go.
There we go.
Yeah. So as I mentioned, every 90 days we review the permit and see if conditions need to change, or if we need to, stop the provisional permit, or if after enough data is collected, maybe we can continue on with the variance to the permit and issue a final permit at a later date. Next slide, please. So the next steps for the Facebook project, obviously, is they need to have the Regional Water Quality Control Board approve their on-site reuse treatment plant so they can become operational. And the COVID, as Don mentioned, kind of delayed some of that work. And then they'll be collecting water quality data and flow rate data for us. Additionally, we had them install flow monitors that we can monitor on a website, through a website, so that we could have real-time flow information as well. They'll be submitting quarterly reports so we could look at the data, and then after 6 months we review the permit conditions and see where we need to go from that point. Of course, they haven't started yet, so the commissioning and final permit we're expecting to be in sometime in 2021. I'd tell you June, but I'd probably be wrong. Just who knows how things are going to go for the next 6 to 9 months here as we're dealing with the this COVID. Next slide there, Don, please. So the biggest local driver for the on-site reuse application was the city of Menlo Park had asked that all buildings over 250 square feet, 250,000 square feet, use an alternate water source for non-potable applications. And at that point where they were designing the buildings, we didn't have a viable project online for recycled water in that area. And of course, the buildings were also required to be dual plumbed for internal use of recycled water. So Facebook decided to go ahead and move ahead with the on-site reuse treatment plant. We did gain some valuable lessons from this permit application, but let's move on to the next slide there, please. And so one of the outcomes of this whole process is we had West Yost help us put together on-site reuse treatment plant waste discharge permit application, because we had permit applications for many different things, but not for on-site reuse treatment plant. And so we were able to come up with a very comprehensive permit application that staff can use, that the permittee can use, and it'll help us out for not only this application, but for future applications. And the next slide will show that we also got a receivable as a manual for permitting the on-site reuse treatment plant. And so it includes guidance for the staff and reviewing the permit applications, how to issue the permits, includes forms and checklists of all the different data we need to collect and the fees we need to collect and those kind of things. And it assisted us with developing our permit conditions. So if we need to incorporate conditions to their permits, which it looks like we will, gives us guidelines for doing that, and guidelines also for doing a provisional use permit, and then of course the final permit. So the next slide. And so some of the lessons learned from this project was, and the biggest one was the developers need to be made aware that the discharge from their on-site reuse treatment plant requires a permit. Facebook didn't realize they needed to come to us for a discharge permit. They thought if they had the blessing from the Regional Water Quality Control Board to install a plant, that's the only permit they really needed. But of course, their discharge goes into our system, and of course, we need to permit that. And so we learned that we need to have talks and discussions with these developers way early in the planning processes. This project wasn't made known to us until it was already under construction. Had we had talks, we could have incorporated a grit removal system and maybe a brine concentrator for the RO system that would have alleviated the need for the provisional permit and some of the variances. But we didn't want to have the project stop, and so we were able to come up with a provisional permit, which provided some variances, and we'll move ahead from there as we gather data. Obviously, addressing the regulators concerned early is the least expensive approach, so they don't end up spending a lot of money on equipment or rework. And the discharge permit, actually the provisional discharge permit, is actually beneficial both to applicant and the permitting agencies. It gives us an opportunity to gather data and get data to decide if our local limits make sense, if there's areas where we can be flexible, but it also helps the applicant move ahead with the project. Don, you want to tackle that last bullet there?
Thanks, Phil. And that's also an important one. As we said, partnering together early can really help build trust and lead to more optimal results. And when we say partnering together, it's getting together and sharing each other's needs, so you can try to come to a solution that makes it work for both. And I think ultimately it was, like I said, the creative minds got together and as Phil mentioned, came up with this provisional discharge permit, which was able to move the project forward. So if that's it for this one, we're going to move on to the Sharon Heights talk, which Phil is going to present. I'm going to stop sharing. You got it, Dennis?
I got it.
There we go. So the Sharon Heights Golf and Country Club recycled water treatment plant is a little bit different story in that we were trying to intercept wastewater up the hill and not pump it all the way down the hill, and provide the golf course recycled water that they could use in lieu of the potable Hetch Hetchy water. They had a need to find a sustainable source of water in case there's droughts in the future, which we know in California there will be. They were thinking that, you know, someday some governor's not going to let them use potable water for their irrigating their golf course, and they wanted to be able to sustain their golf course. And so we spoke with them and came up with a partnership, really, on putting together a treatment plant there on their site that would intercept wastewater that was coming down the hill and recycle it for the use of irrigation for their golf course. Next slide, please. So there's three big pieces to the treatment plant. There's the influent pump station that takes the raw wastewater and pumps it up the hill to the treatment plant. The pipe alignment was a great success story. That we took the force main that goes from the raw water pump station to the treatment plant and moved it off the road. That worked well. And then the treatment site facility itself, we'll talk about that. The next slide shows these project elements in a map view. And so you can see the treatment plant on the left, where the recycled water treatment plant is about 1/2 MGD in size, and it's located on the golf course. They're next to Sand Hill Road, bounded on one side by Sand Hill Road and another side by I-280. The influent pump station on the right takes the raw wastewater that I mentioned, and pumps it almost 2 miles up to the Sharon Heights Golf and Country Club treatment plant through the purple force main that's there along Sand Hill Road. The original project and encroachment permit that was applied for through the city of Menlo Park was to install the force main on Sand Hill Road. But on the next slide, we'll talk a little bit about the pump station, and we'll get back to the force main. But one of the neat things about this project, we did some drone videos, and I don't know if this will play here, but this is a quick little snippet. But you can see the pump station is below grade, and all you see from the street is the vaults. And there is a control panel there on the side street island, not on the main street island, that we've since installed some shrubbery and painted it green to make it less visible and improve the aesthetics for the neighbors there. The nice thing about having the pump station underground is it didn't cause any problems with the street for the neighbors or parking. The pump station consists of two 35 horsepower pumps and only needs one, but there's two so that it can have redundancy. And but there is 265 feet ahead that we need to overcome going up the hill. Yeah, and the next slide there shows the pipe alignment. So we had moved through the design build process that we were involved with. The value engineering portion of that really paid off in moving that pipeline out of Sand Hill Road and onto the walking path. There's a walking path that's parallel with Sand Hill Road. It is roughly the path we wanted to follow to get our raw wastewater pumped from downhill up to the hill, top of the hill where the treatment plant was. By doing that, moving that, it took the impact of the construction on the traffic on Sand Hill Road. And if we go to the next slide there, it also improved the walking path. The walking path was was old and needed some repairs. And by us putting the pipeline there, we reconstructed the walking path, and it looks really nice. And it came out to be a benefit for the whole public and the project. And the city was delighted to mitigate the impact of the traffic. All right, then the next slide just is a nice picture of recycled water being put on a golf course. So there's 50 million gallons a year that we're expecting to be able to produce with this recycled water plant. And we're targeting 400,000 gallons a day for the use of the irrigation of the golf course during the summer. They actually use a little bit more than that, and but we're pressed to get quite enough to get any more wastewater to be able to turn into recycled water in that area. But the treatment facility here is a membrane bioreactor plant, and we were able to use the slope of the location to produce a forward feed to reduce the reliance on pumping the wastewater from one process to another. We were able to use gravity. That helped reduce how many pumps we had to have, how much electricity we use. And again, as I mentioned, it's a 500,000 gallon plant. Turned out to be quiet and odorless, and actually pretty well screened from the golf course, especially with all those trees on the right side. We'll talk more about that. The next slide shows the headworks where the raw wastewater enters the treatment plant. And it's just a real quick video, but we also learned to use some of these videos from inside for training purposes for our chief plant operator. The next slide will show a little bit more detail about the slope. You could see the slope coming down there on the left side of the facility. And that helped us, as I mentioned, to be able to use the forward feed to reduce the pumping. So that was one of the benefits of value engineering in the design build project. The next slide will show the membrane bioreactors. And this is just a photo of the cassettes. Oops, if we can go back there. Oh, can we go back one slide? There we go. Yeah, thank you. So it's this spaghetti-like twine, I don't know what you call it, but it's the membrane that filters the wastewater. I mean, there's thousands and thousands of this spaghetti stuck in each one of these panels. Then there's about 15 panels on two sides there. So there's about 30 panels on each side, or in the whole cassette. And of course, when that's wet, it weighs a lot. So we had to install a gantry to lift that up when it needs maintenance. So that's the membrane bioreactor. And the next slide there is a little video that shows some of the odor control and the screening that we installed there at the treatment plant. So those green tanks are the odor control. The large tanks are the bio-trickling filters, and they do the bulk of the heavy lifting to reduce the odors and mitigate any odors that might emit from the treatment plant. And as a backup, as a redundancy, we installed the activated carbon smaller tanks there. And they've not even been used yet. But in the case that it gets overwhelmed or overwhelms the biotrickling filters, those activated carbon tanks can take over. This is just a drone shot of the golf course. And on the left side, it'll show how well the treatment plant is screened from the golf course. You can see through, this is during construction, so there's a lot more trucks there during construction than while it's operating. And we also installed fencing. If we can go to the next slide there, interrupt this video, please. So we installed some fencing and of course some landscaping that will, as it matures and grows, and we'll do a better job even of screening the facility. Okay, the next slide will show the ultraviolet disinfection units. So there's two there. It runs on one, but we need a redundant system. And I think there's 32 bulbs inside there that disinfect the recycled water that then from here goes out to the golf course pond, and where they pump it onto their facility. The next slide, we'll talk about the public-private partnership. So the district entered into, I think it jumped ahead a few slides. So the district worked with Sharon Heights to develop a long-term agreement. There we go. Whereby the district would fund the project, and we got SRF loans, state revolving fund loans, and we even got 5.2 million of a $22 million project as grant. But the long-term agreement commits the Sharon Heights Golf Course to pay us back for the capital expenses. It also requires that they pay the annual O&M for operating and maintaining the treatment plant. As I mentioned, we were able to secure a state revolving fund loan at 1%, and 5.2 million of the 22.5 million was grant. It was a progressive design build project, and in a few more slides, we'll talk about the Caltrans fill station and some of the negotiations that had to go on for that. So, as I mentioned, the project price was 22.5, a little over. The project had been completed, and we actually came in about $300,000 under budget. As I mentioned, it was 1% interest, 5.2 million of the 22.5 was grant, and we operated on 5% contingency, which is actually a pretty small contingency on a project of this size. The district had to commit to $8 million of cash flow reserve to be able to pay the contractor as the project went on. But in the long-term agreement, we also had provision for the golf course. If we exceeded that $8 million cash flow reserve, if we weren't getting our reimbursements back from the state quick enough, that they would have to participate in the cash flow to be able to keep the project going and get it done on time. All right, next slide, please. So the Caltrans permit. So when we moved the pipe alignment off of Sand Hill Road and we put it in the walking path, then we found ourselves needing to use the Caltrans right away for our pipe alignment to go through rather than just straight across. That consisted of a longitudinal variance from their encroachment permit. That took 18 months for us to acquire. So that was a lesson learned, but it did still help the value of the project. It reduced the cost of the pipeline, the force main pipeline, and it also mitigated almost all the impact to traffic on Sand Hill Road. So it was still worth it. We were able to work on the treatment plant itself and the other parts of the force main while we were waiting to get that permit. We got it just in time to go ahead and move the construction along without hardly any delay at all. And it worked out good. The only thing that Caltrans asked for was they wanted a fill station where it says Phil's Fill Station. They named it Phil's Fill Station. So Caltrans could have their street sweepers plug in there and get recycled water to do the street sweeping on the freeway. Okay, so I know we're running out of time, but so we'll get moving here ahead real quick. This is a time-lapse photography. We had a camera posted at the site so we could document all the construction activities. But it gets really long on a long project like that, and it gets hard to find a particular point in time where you're looking for a certain kind of or portion of the construction. But you can kind of get the gist of the work that was done. They dug the hole, they put in the forms, and they poured the concrete, and then eventually you get to the ground level and you start building the operations building, the headworks. All those kinds of things. And so this was good. It was helpful. However, we discovered that drone videos could give us a unique perspective, and we can move it around. Where the time-lapse photography, we're kind of stuck in one point. But that's good and bad. But anyway, if we can forward to the next slide there. And it'll show the completed site. That's what it looks like today with the big turnaround. So if we had chemical trucks that come deliver chemicals, they can turn around and get back out. But you can see we use the slope there to our advantage for the treatment facility. And the next slide shows that we're actually delivered recycled water to the Sharon Heights golf course. And so We began delivering on July 27th, and I think we've delivered about 19 million gallons to date. And in 2021, we're hoping that'll grow to over 50 million gallons. So lessons learned. The Caltrans permit is something we didn't anticipate while this video runs. I'll talk about some of the lessons learned. And but it did provide us with great value. And so it was definitely worth it. It took a lot longer than what we expected, but because the design build engineers and contractors put their heads together, they decided they could do a lot of the construction while we're waiting on that permit. Wipes became a problem. We didn't anticipate the wipes being a problem at that treatment plant, but because of COVID, as soon as we started doing our testing, everybody was using wipes instead of toilet paper because they were running out of toilet paper, all that stuff. So we used YouTube and Facebook ads to target zip codes and newspaper articles and everything else to convince the public to discontinue the use of the wipes because it was causing problems at the treatment plant, and they responded very heroically. It was a terrific success story in public outreach. We ended up changing the screening a little bit, modifying the screening to adapt to some of those wipes and some of the other debris and grit that was coming to us. COVID-19 was a lesson learned. I'm not sure we'll ever have to use that again. I hope we don't. But the public-private partnership was a huge benefit that we were able to take what was considered a waste in the past and turn it into a resource for the benefit of the whole community. So now there's the whole city of Menlo Park benefits from having the potable water used for the citizens rather than for irrigation of a golf course. A bioassay was something we learned we had to do. We thought recycled water on a golf course wouldn't require a bioassay, but it does indeed because the source is wastewater, not lake water or something a little cleaner. We learned to talk to regulators early and start our Title 22 a little bit earlier than we did, even though we got it all done, but a little bit of pressure there. So we also learned that borrowing money from the state and getting grants from EPA requires that there's a disclaimer, and that you have to use for all your public outreach, any brochures, any advertisements, and even in your presentations. So in this presentation, you will see a disclaimer that says the funds, this project was funded in part or all by state and federal funds. And those are some of the things we had to do. And we learned that drone video is super helpful, super cool, and really helps you tell a great story to not only this project, but I'm imagining you could use all kinds of other projects. We used drone video to go to the Army Corps of Engineers and show them their site where we're going to put another recycled water facility down on Bayfront, and they decided that they were going to make that a requirement for all applications in the future. So I don't know if that's a good thing or a bad thing we did, but anyway, those are some lessons learned. Here's some of our partners, and then of course Summit Aerial is the folks who put this video together. All right, with that, I think that sums it up for us.